This is part 3 of making electricity work for Year 9 physics. And this little part is on cells, batteries and ammeters. So what is current? Now we've already mentioned this in the previous 2 parts, but current of course is a flow of electrons. So it's a flow of electrons through conductors in a circuit. And that, of course, is where electricity gets its name from the elect bit of the electrons in a circuit. Current is measured in amperes, which is the surname of Henri Ampere, who discovered or who named current, and we shorten that to amps. And the symbol we use for amps is just a capital A. Now, if you have a look up just at this diagram of the atom, you can see that in an atom you have got a nucleus and then you've got electrons moving in what we call shells around the outside. In conductors, conductors are special because conductors have electrons in the outer shells which are able to move between one atom and the other. So if you've got a piece of copper, then in that copper wire you have got atoms who have electrons in their outer shells which are just hopping from one atom to the other very randomly. But if you connect that into a circuit, then the electrons, those what we call them free electrons, move in the direction of the positive terminal of the battery. So they move towards the positive terminal of the battery, and that's what current flow is. So some of their electrons can move from one atom to another in the conductor. In insulators, the electrons aren't free to move from one atom to the other. They're very, very tightly bound by the nucleus, or they're attracted to the nucleus, and so they can't move, and therefore electrons can't move in insulators, and that's why they don't conduct electricity. They don't allow electricity to pass through them. Right, a little bit about cells and batteries. We've already mentioned cells and batteries. So a cell is made up of 2 ends. Generally it's a container which has chemicals in it, and one end of the cell has a positive terminal and the other end has a negative terminal. So a cell is the source which pushes the electrons around, and we say a cell has energy, or provides energy, I should say maybe provides energy to push electrons around the circuit. And its symbol then is this symbol here. And the long part is the positive terminal, and the short part, and it's normally quite a short and fat part, is the negative terminal of the cell. So whenever you connect that into your circuit with a lamp and copper wires or copper leads, then all electrons in the leads all start moving at once, and they move around the circuit and they move through the lamp. They lose some of their energy as they move through the lamp and make it light up. So the symbol for a cell is like that, and the long part's positive and the short fat part is negative. So a battery is a combination of 2 or more cells. And its symbol is already given here. You show it just with the 2 cells beside each other, and you connect a line between the short fat part of one and the tall thin part of the other, or the negative and the positive. So that would be positive, negative, positive, negative. And you must connect those cells positive, negative, positive, negative. Otherwise, if you turn this one round, and I'll just draw that, if you turn this one round so that the short part is facing the short part, what they do is they cancel each other out. So because this is the wrong way round, then the negative part, this battery here is cancelling, or this cell is cancelling out the other cell. Okay, now any battery or cell that you connect into a circuit has a voltage, and the voltage is the energy which pushes electrons around or current around a circuit. So voltage is the quantity or the thing that you're measuring, and it is measured using a voltmeter. And you already know its symbol, and its symbol is a V with a circle around it. And it is measured in volts, V-O-L-T-S. Now, most of the cells that we use in our everyday appliances have a voltage of 1.5 volts. And when a number of these are put together, they make up a battery. So if we have a battery like this, you have a 1.5 volt and a 1.5 volts. So altogether inside that battery, you have actually got a total of 3 volts. So there's a question, how many 1.5 volt cells would be used to make up a 9 volt battery? So we have to divide 9 by 1.5. 1.5 into 9. And 1.5 goes into 9 6 times. So the answer is 6 cells. Okay, the last part of this, measuring current. So we've already said that current is measured in amps or amperes. It's just a repeat there. And the symbol we use is a capital A. And current is measured using an ammeter. Now, all these meters in physics all end in have the ending ER. The only meter that we use which has got an ending of RE is the meter ruler that we use for length. When measuring current through a component, the ammeter is always connected in series, and we'll be saying a little bit more about series and parallel in a minute. But series is in the same loop, so it has to be connected somewhere beside it. And if you have a circuit where you want to connect an ammeter in, you must take out a link and make a gap to put your ammeter into. And therefore you must connect the positive side of the ammeter to the positive side of the cell, and the negative side then, if you follow that on round, should be connected to the negative side of the cell.